Good morning. Today we're going to see about the concepts of friction. Let's start with the introduction of friction. Friction is nothing but when an object or a body or anything that moves, it will get in contact with any surface. The force exists between the contact surface and the object. In between those contact surface and object, the friction will occur over there. If there is no friction in an object, the object will automatically slip down or it will fall down. So when a body moves or tends to move over another body, a force opposing the motions develops at the contact surface. That is known as the frictional force. The force which opposes the movement or tendency of movement is called the frictional force. In general, the frictions are classified into static friction, kinetic friction, and rolling friction. The static friction, for example, we can place a ball over a table. The nature of the ball is to roll. If we apply any kind of force, if the force is very minimal or it is maximal, the object will start to move. When there is no force acts on that particular object, it will be in the rest mode. So it is known as static friction. Here there is no external force acts on the object, so the object is not moving anywhere. So it is known as static friction. There also a friction acts. Just imagine that if the table is in not in the horizontal state and if it is in an inclined state, the ball will move in downward directions. So here since the ball is in the the table is in the horizontal surface, the ball over the horizontal table is in the rest mode. It is known as static friction. Here in the second condition, if we are applying a force, to that ball, then the ball starts moving. It is known as the kinetic friction. In the rolling friction, at the initial stage itself, when we want to place the ball in the ground with some force applied on it, when the ball starts moving from its initial position, it is known as the rolling friction. Here are basic laws of dry friction to explain about the coefficient of frictions. Just imagine the two blocks. Here in the two blocks, in the block 1, there is no external force acting on it. This is the block 1. In this block 1, there is no external force acting on it. So the blocks remains at static condition. The normal reaction force acts perpendicular to the lying plane, opposing to the weight of the block. In the second condition, this is the second condition. The second condition, the ball starts, the block starts moving to the applied directions. Therefore, the frictional force will be in the opposite direction. The frictional force will be in the opposite direction to the applied force. Here is the applied force. The frictional force will be in the opposite directions. The self weight of the block acts perpendicular to the ground plane, and the reaction force, normal reaction force, acts perpendicular to the lying plane, opposing to the weight of the block, opposing force to the weight of the block. This is what given in the diagram. And it will be in the equilibrium conditions. Whenever the force, that is the applied force, exceeds the frictional force, the object starts moving. Till that, the system will be in equilibrium conditions. That is what explained in this graph. When the applied force is keep on increasing, at some state, the object starts moving by breaking the condition of equilibrium. Then the kinematic frictions will be there. The general formula for the frictional force is Fm is equal to mu into N. Fm is equal to mu into N. For the static conditions, we'll apply the Fm is equal to mu s into N. Mu is the coefficient of friction. Whereas in the kinematic friction, Fk is equal to mu k into N. This is what given in the slide. Here, based on the conditions given in the image, we have to find whether the object is in moving or about to move or it is in motion. Here in the first case, as already we've seen that there is no applied force acting horizontally. The applied force is vertically downward. So there is no need of frictional force. The body is in static conditions. In the second state, the body doesn't move because the applied force is lesser than the frictional force. So in this case also, there will not be any movement in the body. The applied force is lesser than the frictional force. In the third condition, the applied force is equal to the frictional force. In this condition, the body will about to move. It is known as the impending motion. We will have a statement for impending motions when the object is about to move. It is known as the impending motions. In these conditions, the applied force is equal to the frictional force. When the applied force is greater than the frictional force, the object will be in motion, that is in the kinematic motions. That is was given in the fourth diagram. To find the angle of friction, tan pi, that is equal to Fm by Nr. Tan pi is equal to Fm by Nr. We know that Fm is equal to mu into Nr. So we can equate the tan pi is equal to mu s. The angle of friction. Angle of friction is between the angle of friction is between the resultant force and the normal reaction. So for finding the angle of frictions, here just imagine that here the weight of the body is perpendicularly downwards. The resultant will occur on this directions. And the normal reaction is which is perpendicular to the lying plane. So the angle of friction will be here. The angle of friction will be here. Similarly, on the different conditions, the angle of friction will occur at different position. So let's see a problem. I hope you all understand the basic concepts. We have seen about the coefficient of friction, what is impending motion, and what is angle of friction. Thank you.